Alright, welcome back um, to more problems from Thomas Jefferson's proof. How does. I just can't believe there's schools that have their own team selection test. That's just so alien to me. Like, wow. Uh, anyways, yeah. So, we have, we have a system of equations is what this is. I mean, it's a little misleading to call it F, but basically the point is that for every, in fact, I'm gonna actually, but basically for every n there's a system of equations, and I want to solve the system. So, for n equals 1, that system is just a1 is equal to 1, 1, 1. For n equals 2, this is a system that looks like a1 plus a2 equals whatever the heck that is. What? Hang on. Okay, so this is the k equals 1 equation. 1, 1, 2. And then for k equals 2, it's, so this is just all the left hand side is just the sum of all the multiples of k less than or equal to, whatever. And then the right hand side, 2, 2, 1. Oh, this is like 1/2 or something? I don't know, man. So yeah, at this point I'm just like, the AI is shorthand for F and I, because that is what it is. All the even ones, all of these things. Yeah, I'm just gonna write down like the first like few examples. I don't know. I think the thing is that if you have, I don't know. I get it's the notation is going to look really annoying no matter what because you have like a doubly indexed. I would probably have just said like let a sub k comma n or whatever, but then the problem is that you're squeezing like a k times 4 n over k into like a subscript, and it's like really hard to read on the typesetting, and they're like, yeah, whatever. Yeah, okay. Anyways, 1/2 of floor 3/2. What the heck is the right hand side? Like these right hand sides are. I understand what the left hand side is trying to do, but I don't see what the right hand side is trying to do. 1/2. 2, 2. Okay, and then 4 is the first time that there's like more than one equation that isn't stupid. So this is 4, a2 plus a4 is equal to 1/2, 4, choose 2, floor 4 over 2, which is like 1, and then it's 3. Yeah, so the thing that's awkward about this is that literally like half the like for every n, like the latter half of the systems is like everything past n over k equals n over 2 is just literally a single thing on the right hand side, right? And then it's like, I don't know. So well, we'll just see what's going on. I want to write down the explicit solution for 4 and see if I can guess what's going on. So here's a2, here's a4. a2 is like 3/4. And then a1 is, whatever the heck a1 is. 1 plus a third, 4/3. That's not correct. Sorry, I don't know how to subtract. What is 8/3? I really should do 6, I think, next. So I think 5 is not that good. I also, okay, so the problem specifically cares about a sub 1. So the other thing you can try to do is like, do this minus plus thing where, Like for n equals 4, it's like first equation minus second minus. Actually, this is minus second minus third. I don't know, man. Mobius out the existence of. No, I think the point is that this is what do you call it? The corresponding matrix. Like the reason it's unique is because it's a system of equations for which the corresponding matrix is upper triangular. It's specifically an upper triangular matrix, with ones on the diagonals. So it will always be invertible. And then the question is just like, well, like something. The other things I wonder whether so I initially thought that you would just like solve each individual system, but it's not clear to me that's the way to go either. Because if you write down the actual like content for 999 and 1000, I think they look pretty similar. Like like you can imagine, I wrote the system for 1000, I wrote the system for 999, and they actually look almost exactly the same. Like most of the things are identical except for like a small number of right-hand sides that change, and like the addition of like B1000 in like a few places. So like, yeah. Also, like if you don't want to think about it, you can just brute force it. that is also an option. Yeah, I don't know. I really don't like the floor end over K. On the right hand side though, that doesn't feel good to me. What if I like no, actually no, that's pretty bad. Like I want this to correspond to being like so floor over K is counting the number of things on the left hand side. Like on the left hand side, the floor is not that unnatural because it's just like here's all the multiples. But then on the right hand side, like what is that floor n over K for? It's saying like the average of the terms is 1 over K exactly, or something like that. Okay, let me write a little bit about 6 and see if I can push it a little more in general. So for n equals 6, I think this is like an interesting case because it has some random like it's like you do 2, 4, 6, 3, 6, 6 kind of thing. And then if you do like plus minus minus plus, you end up with just A1 left over. Yeah, it's possible I don't need most of these equations. Maybe that's what's going on. It's just maybe I only need the ones where K divides N, and then you just run it over. So for general N, Okay, for 5 I need like, oh no, 5 is actually a better example than 6, I think, because for 5 you need like 2 4 3 5. What the heck? Like for n equals 5 you have 1 2 3 4 5. It's like 2 4 3 5. It's like plus minus minus plus. Sorry, no, it's just plus and then minus minus minus. Hmm. Yeah, I feel like this feels better to me than solving the system because it's what's happening is like the answer is independent of certain equations. Like for example, for n equals 5, we don't need the equation for k equals 4. So it's like only some of the values are being read. I think you can even do just plus minus 1. Maybe. As another thing, like when you have, suppose you are going from like 1 to 100, okay, then a sub 97 is only read in 2 places. Like it's read for k equals 1 and it's read at k equals 97. So it's kind of yucky. But like, I don't want to add harmonic things. Is the thing. Okay, I'm convinced the answer extraction matters, because when I'm thinking about what like a sub 1 is for like the equation that goes from 1 to 1,000, that denominator is going to be horrendous. Like there's like plus 1 over little primes for like a ton of large primes, every prime between 500 and 1,000. But then it will like very neatly cancel all the corresponding primes for f of 999. So I definitely, yeah, like the f of 1,000 minus f, the way the answer extraction is phrased does matter. Like you expect almost everything to cancel, and then the question is like what stuff doesn't cancel. And okay, all right. So the only question I then have is like these weights that I've been trying to come up with. Do I think the weights are like okay? Because I can do like this n equals 5 and 6 by hand. Or should I be like trying to? How do you do the weights? Is the weights like some Mobius crap? So for a given, if I do this algorithm, the weight for a given AD, so the weight of the dth equation should be the negative of the, I shouldn't use d, sorry. Let me use, oh fuck, k's already taken. Shiba! We'll use r, alright. Should be the negative dr of wd. Okay, so it is just the Mobius, right? Thing. Wait, is it really Mobius? I feel like I was trying to. Oh, it's Mobius. Why did I think it wasn't? Wait, it is just that, right? Shiba. Yeah, this is why I'm stupid. Okay, I forgot this minus a5 here. My bad. Yeah, okay, it's Mobius. There you go. So, so for n equals 1000. Okay, sorry, this is just the explicit. How did I not notice this earlier? Okay. For the 1000 thing, it's like the sum of the. How do I write this? It's like. Alright, let me get this right. K less than or equal to 1000 of the Mobius function of K times. Sorry, this is probably all negated, isn't it? And this is like less than. No, not negated. Okay, the expression was 1 over K floor n over K. And then the corresponding expression for 99 is given by very similar thing, except, well, okay, sorry, I should fill in the 1000 here. Yeah. Yeah, like what's happening is that the way you determine the let me walk through the weights for the people who haven't seen it before. The way you determine the weight is you put the weight +1 on the first equation, and then for every equation after that, you put a weight that kills off the weight on the kth equation should kill off all the AK terms. So for example, when you did n equals 6, you first put a plus weight on the one thing, and then to kill off the A2, you put a minus weight on the second equation. Then you look at the third equation, you have A3 so far, so you go here. For A4, there's no weight because this thing and this thing already cancel. 5, you put a -1, 6, you put a -1 to cancel the 1, -1, sorry, 6 is +1, yeah. So that's what's going on. And then if you've seen this before, this is the recursion. It's like, it's the negative of all the previous weights to kill off those things, and then it turns out W is just the Mobius function. Yeah, so it's just Mobius inversion is the... Okay, anyways. So now I need to subtract these two things, and like the main thing is that for almost all values of K, like floor of 1000 is equal to floor of 999. So, the only values for which they're not equal are the ones for which K divides 1000. So the difference, for those values, the difference is equal to just 1. So it's like difference of K dividing 1000. Yeah, so for the bottom sum, this floor is equal to 0, so it's also okay. So honestly, like I could technically drop these two and nothing changes. Because the floors will vanish anyways. So the difference is the floor of K, the difference is sum of K dividing 1000 of Mobius K over K. And this is a multiplicative function. So basically what that means is I can factor it as, well actually also, okay, I don't even need to do that. It's only like, there's only a few, like, it's like 1 minus a half minus a fifth plus a tenth. Those are the only values for which mu K over K is not 0 anyways. Which you can, if you want to be fancy, it's like 1 minus a half times 1 minus a fifth. Doesn't really matter, answer is 2/5. Did I get the final number right? Cool. Alright, we're done. Yeah, it's kind of weird because this floor... I think you could have phrased this in a way that made it less, floory or something. Like, well, actually, I don't know. So the problem is you need two systems of equations to do this. But I think you could have at least said that, like, from an aesthetic thing, if you said that 1 over K is the average of AK, A2K up to whatever. You could have written this thing with no floors, I think, and it might have looked a little better. I mean, same problem, of course. But anyways. Okay. Yeah. Yeah. It's probably not how I would have set up the notation. Well, the thing is, like, 1 over k didn't matter. Like, you could have used, like... Well, I guess if you use 1, then the answer is just 0. But if you used, like... But we could have used literally anything. Like, because the answer is, like, whatever this function is, minus evaluated at 1, 2, 5, 10, and then, like, you know, glue them together. So then I have this question, which is like, why have I not seen this before? Because I feel like I should know. Okay, whatever. I probably just didn't recognize it. I'm sure that somewhere someone has given me like a system of n equations where the weights cancel out in Mobius fashion. Like I think there's no way this is the first time I'm seeing the left-hand side of this system. I just didn't recognize it. I can't think. Do people know other problems that have that same system on the left-hand side? I don't care about the right-hand side. The right-hand side doesn't matter. But I feel like I must have seen this particular system before. Like, not even Mobius. Like, I know I've seen Mobius stuff, but I feel like I must have seen the particular system before. Okay, whatever. Let me write this up. Well... Okay, let me quickly write this. I don't think this will take... I'm gonna just sketch it because I don't really want to write out the full details, but... 137.3. So the basic claim is that fix an integer n at least 1. Consider the system of equations given by in n variables x1, x2, given by so you have like a constant c1 is like x1 plus x2 plus plus dots. And then the next thing is x1, x2 plus x4. Does my editor not conceal dots b? That is actually I need to fix that. Cn is equal to xn, where the kth equation. Well, let me write out more terms so it's more obvious what the system is, because this is. X, n, k for n over k on the right hand side. And the claim is that sum of a Mobius k less than or equal to n, uk, ck, where mu is a Mobius function. And the proof is the coefficient of if we substitute in the expressions for ck on the right hand side, the coefficient of xi is the sum. Let me write m. Is the sum of k dividing m of mu k, which is known to be 1 for m equals 0. For m. Okay, so applying this directly here, we get alpha of 1, f sub 1001 is equal to the sum of k less than or equal to 1000 of mu k floor 1000 over k. And the same thing for 999. Okay, and then subtracting, final answer is literally sum of k divided. Yeah. Note that, let me just write explicitly that floor, the difference of the floors is exactly okay, I think this should be displayed. So and then, yeah, 1 minus a half minus a fifth plus a tenth equals 2/5, and we're done. Yeah. No, I feel like I must have seen this exact system somewhere. I refuse to believe this is the first time I'm like seeing this particular system because it seems so fundamental. In fact, gotcha. Ta-da! This one's a little different. I don't think this one actually... This one's a little more complicated because there's a lot of non-trivial analysis involved because if you try to apply Mobius directly to this, you will burn yourself because none of the things involved are absolutely convergent. But yeah, I was like, I must have seen this exact system somewhere, and this is one example where you want to determine whether the infinite version of this has a non-negative solution, where the answer is no. And not only is it no, this version actually has like this nice interpretation where you can ask yourself, is there a way to assign a probability AI over the positive integers such that in this probability distribution, the even numbers have weight 1/2, the multiples of 3 have weight 1/3, etc. Yeah, and the answer is no. But yeah, so yeah, a measure. Yeah, it's like, is there a measure that for which the multiples of n have weight 1/n? And the answer turns out to be no. Yeah. Okay, cool. So I am not crazy. I was like, I must have seen this somewhere, but I was trying to remember where. Amazing. Okay. All right, so that's that. Yeah, Mobius function shows up again. Thank you for tuning in. And yeah, I don't know. How do you do this outro thing? Well, yeah, okay. By the time this makes it up to YouTube, I think it will probably be 2024 or almost 2024. So, happy difference of squares year. See y'all.